Intel asked me to start by reminding you that I'm using mini media trademarks and copyrighted material to make my points in this deck, but those names and brands are the property of other people, not the property of Intel. So I'm Ned Hayes, and I'm a Senior Technical Solutions Owner at Intel, and I'm speaking about AI and ethics and the design of algorithms. So I was inspired to give this talk by watching episodes of Silicon Valley. There's an actor on this show who said that he was seeing some problems when he did research out and talking to the technical community. And Kamal said that when he talked to technical decision makers in the Valley, they were doing all sorts of cool ideas, and they weren't really thinking through the ethical considerations. In fact, zero consideration was given to the ethical implications of technology. Now, I know that a lot of leading technologists and decision makers in tech are actually thinking about ethics. But if this is the perception, we have a problem. So let's talk about ethics in tech. This is an important point to talk about it because you're seeing in the news, Amazon, Google, Facebook, all are facing decisions with billion-dollar market implications, all of which have ethics as an underpinning question. So when you think about AI and ethics, you think about something like the Terminator, for example. You know, it's an ethical consideration. Smart people like Elon Musk are even saying, there could be problems with AI. AI is a bigger threat than nuclear weapons. And, you could think about a movie like Steven Spielberg's AI, where you have kind of a Pinocchio story of a young android who tries to discover himself. And most non-technical critics thought it was pretty good, except for the aliens part. And that was entirely unrealistic. But let's move past that and think about AI and ethics from a science fiction historical perspective. Isaac Asimov came up with the 3 laws of robotics, which included a robot not harming human beings, a robot obeying orders given to it by human beings, and a robot preserving its own welfare. So those 3 rules seem to be important when people were thinking about AI way back in the 1970s. Now, all of these constructs have problems. The question of ethics has become really interesting to people who actually don't work in tech today. So all of these don't really unpack the complexity of real-world algorithmic design or provide concrete answers. I don't have all the answers, but my goal here today is to provide some open areas for discussion and some possible answers to explore as we design today's technology systems. So reality isn't as simple as Asimov or as other technical decision makers seem to think it was. For example, when you're designing an autonomous vehicle, you could have a 15% chance of hitting one person, you could have a 60% chance of maybe hitting 2 people, and maybe you wouldn't hit anyone at all. So when an automated car is making decisions about motion, it's not a decision that is a binary twist. By the same token, when you're looking at machine learning training, you can see all of these different components: trained models, optimized models, inference engine, all of these pieces that I work on at Intel in computer vision. Notice the absence of a black and white decision point. There is no point at which a bit is flipped and the system says, be evil. That doesn't happen. By the same token, here's some inference loop code. So this code right here doesn't have black and white decision making in it either. It doesn't show a point at which a decision is made that could harm a human being. Isaac Asimov's rules might not apply so cleanly here. The real world of ethics and decision making is not a world of fantasy robots. Robots have not yet arrived, you might have noticed. And if you look at how people are predicting AI, they tend to over-predict. Like Cory Doctorow says, smart people are believing really dumb things about our future AI overlords. These things haven't happened. They may never happen. So algorithms, a system of instructions that are used in a machine, that's what our systems are being designed with today. So let's talk about how real-world algorithms are designed and how to think ethically about them. So first of all, this is a whole system of algorithmic complexity. So since I work in computer vision, let's unpack this system. At the very top, you have an image and a video. You can identify that there's an image there. You can tag that image with a location. You can also understand that there's a crowd there, that there's a person in the crowd. You can do identification of race and age and health. All of these factors are important when you're understanding the data within that image. Then you can go further and you can match that data against databases and match that person, once you've identified them, against past activity. And finally, you can understand proximity of those people to other people. So you can match that person to potential future activities. It's a little bit like another Spielberg movie, but it's not necessarily smart AI. All of these pieces are part of the algorithm that goes into computer vision. So if we look at this algorithm in a real-world scenario, we might have this crowd. And in this crowd, I can identify which things are people. So I can say, these are people. These other things are dogs or signs or cars, but these are actual people. And here we can actually identify faces. So I can say, this person, that is their face. That's the expression on their face. And then I can go a step further and understand the individuals by matching them against the database. Now, this is where it becomes a little bit problematic, because we can match against this person and say this profile matches a bank robber. We might want to do something about that. This next profile might match against somebody who is performing suspect activity in a crowd. Maybe they look like a pickpocket. How they're acting might look like a pickpocket. And the next person, they match against a political refugee database. Maybe ICE is doing this right now. Maybe ICE wants to interrogate this person. The next person might match a race and gender that we want to kill. Now, someplace in this system, an ethical line was crossed, but where exactly? All of these are valid scenarios for what you can do with the data, but are these all ethical scenarios? Perhaps they all are, perhaps none of them are. This is the question we're going to talk about today. So all of these algorithms here and all of the instruction sets were designed for good purposes. People had good outcomes in mind, but they can be used for crime prevention and control. But that can also go too far. As you can see, the Department of Justice is investigating some of these activities. And in other countries, they even use the same exact algorithms to monitor ethnic minorities, to monitor religious beliefs, to monitor things that in the United States we don't think are ethical. And we actually consider illegal as well. We'll talk further about that in a minute. So how do we draw a line between good and evil? It's not so easy. The idea of ethics helps us to make some decisions around what to do. So we might first ask, what is ethics? Is it just the same as legal behavior? Is it just the same as my religious beliefs? So let's talk a little bit about the distinction between ethics and other ways of thinking. First of all, ethics is not just legal. So this identification of a group of people was a legal activity. It was used by a government during World War II by the Nazis to identify these people and kill them. Totally legal. The Germans at that time were scrupulous about following the letter of the law. If you follow the law, you might still be acting unethically. By the same token, during World War II in another part of the world, people were identified by their national origin or their face. And this was used by the United States to identify people who were citizens and put them in camps. This might have some resonance today. Identifying people by racial characteristics can be unethical even if it's legal. And then right now, there are countries that are using automated systems like drones to analyze behavior and actually target people for either interrogation or killing. This is also considered legal, but it's unethical according to the United Nations. So all of these things complicate the picture. When you're designing technology, it could be ethical and legal. You could design something that says, you download the software, you write a document, and you pay for that privilege. That's a legal, ethical act. But you could design something that is legal, but not ethical, as we just saw with the drone idea and other activities that human beings engage in, like prostitution or gambling or neglect of family members, those things might all be legal, but they might not be ethical, depending on your personal ethics and the ethics of your community. And then, of course, there are things that are not ethical and are also not legal, like murder, sexual harassment, a variety of activities that are seen both as non-legal and non-ethical. And finally, you can do things that are ethical but are not legal. For example, in some domains around the world, political protest is ethical but not legal. Fighting unjust laws is also ethical but not legal. And reporting police abuse can be ethical but not legal. Ministers face these questions all the time when they choose their own personal ethics instead of the laws of their land. So it's a complicated environment that we work within when we design technology. It's not a simplistic black and white answer. Ethics is also not religion. I talked a little bit about ministers a moment ago, but let's talk a little bit about what it means to be ethical and religious. So first of all, ethics is not the same as religion. A religion is an organized set of beliefs, a collection of beliefs that make claims about moral behavior, but it's not quite the same thing. Ethics, for example, are a logical, rational construct that don't rely on beliefs that go beyond the rational world. Now, the tricky thing about this is that the majority of your users of technology around the world are actually adherents to different religious beliefs. Many, many people around the world believe in religion. So it's incredibly important to be sensitive to religious beliefs, even if you don't hold any yourself. Now, what's interesting about religion is that there are some shared ideas across religious cultures and communities that can be used for ethical decision making. The Golden Rule is one example. Hinduism, Confucius beliefs, Buddhism, Judaism, and Christianity all share a common golden rule of treating others as you would want to be treated. There are other examples of this, and it's important to keep in mind that religious beliefs do inform people's personal ethics, but it's not quite the same thing as ethical decision making. So, to be clear, your tech designs are not just chaotic neutral. It's not possible to design a system that could be used by anyone in a neutral way. Your technology will probably be misused. That's the reality. So how do you build protections in? First of all, when you think about ethics, think of it as a tool in your toolbox. This is a decision-making tool set. It's based on logic and reason, not based on tradition, injunction, or religion. It's a branch of philosophy. It's been there for centuries as part of philosophy, going all the way back to Plato and Socrates, and it helps you to think about right and wrong conduct. So one example of academic ethics is the trolley problem. You might be familiar with it. Basically, this posits, what if you had a piece of technology, a trolley in this case, and that trolley could strike 5 people or it could strike 1 person, and a decision maker, either you as a technology design person or maybe your user, has to pull that lever to decide which people are hurt by this technology. By the same token, if you think about this problem in terms of exposing data, are you going to expose, let's say, the head of a country's data, or will you expose the data owned by 500,000 citizens? Which is more important? Where does that decision-making rule fall? And who gets to make that decision? So this is just one example of academic decision-making in ethics. And ethics also can change based on culture. So this is a common trope in autonomous vehicle design. For example, here's a crowd. Your autonomous vehicle will strike one of these people in the crowd. It could strike the young person. It could strike the older person. Depending on your culture, you might make different decisions. So it's important to keep that in mind, that depending on where your technology is used, your decision-making ethic might change. So just to be very general about this, in Asian cultures, often the elder is privileged versus European cultures that privilege the child. How do you replace 80 years of experience and knowledge and wisdom? Asian culture would say, generally, preserve the older person, and European culture would say, preserve the child. These are cultural distinctions that are generalizations, but it's important to keep that in mind, that there are cultural import to what your technology can do. Another example, just on the side, is that a friend of mine was working on a system to do facial biometrics across the world to do identification for people's health care. So you could identify when somebody walked in a room and provide them with the appropriate health care. This worked great until they got to certain areas of the Middle East where it is improper for a woman to show her face to someone she is not married to or otherwise related to. So in those villages, they got every male registered, but no female faces. So the culture itself made it impossible for their technology to be effective. So you need to be aware of what the ethics and the rules are in the culture that your technology will be deployed. So it might be important to ask, why act ethically? Why can't I just design something and put it out there? Let's talk a little bit about why you might want an ethical piece of software to have your name on it. First of all, this goes back to the question of ethics that I talked about near the beginning. You might want to stay out of prison. Everything that happened in Germany between 1939 and 1945, totally legal. And yet people went to trial at Nuremberg and were executed for unethical acts. So you yourself can be prosecuted for actions that take place within your technology. So stay out of prison. There's another good reason, and this is one that's often overlooked, which is that an ethical society and ethical decision-making by businesses actually creates a more stable and predictable society and economy. You can look at this in the difference between India's growth and China's growth. India has taken noticeable steps to reduce corruption, while China still has a corrupt society. And so India's growth has been astronomical, and the economic miracle happening in India is partially due to the enforcement of ethical activity on the part of business. So bribery and creating unethical situations actually cost the larger economy because businesses can't rely on you to be stable and predictable. Your business could move because someone's cousin got appointed instead of moving for good business sense. So when you act ethically, you create a more stable economy for everyone. A rising tide lifts all the business boats. And the third reason is that companies with ethical standards actually make more money. This has been proven time and time again. The Wall Street Journal and Forbes have all done studies on this, and companies that act ethically make more money. Intel is proving this today. Intel sources all of our minerals in all of our chipsets from conflict-free regions. That makes our chipsets cost more. We do it because it's ethical. We don't accept blood money for putting materials in our chipsets. And we are actually making more money because we are upfront with our shareholders and with our consumers about our ethical practices. Intel has done the same thing with inclusion and diversity initiatives within our company. And we're on target to exceed the norm in the technology industry for diverse and inclusive campuses and teams across the industry. This is better for our company and better for society. And finally, the third thing is, wouldn't you want to be proud of what you built? Wouldn't you want to be able to go home and explain, I built that thing, it's a good thing, rather than being ashamed of something that rips people off or that does something that is unethical or wrong? So all of these decisions have a real impact. They have an impact on human rights, and your technology decisions, as you can see here, actually change what happens with people's well-being. So if that's in autonomous vehicles, if that's in where you locate your factory, if that's in how you're surveilling people and doing computer vision algorithms, all of these things have a real-world impact. You can look at this later, and this is also up on my website, where it unpacks all of the impacts that your decision-making can make. So let's talk a little bit about real-world algorithmic design and how to use ethical decision-making to make your algorithms more secure and more ethical. One of the AWS architects at Amazon talked about being an architect, and the job is to ask awkward questions. That's also your job as an ethical architect or ethical decision maker. Your system should be designed with ethics in mind. So your job is to ask the awkward questions about ethics. So here are some of the awkward questions. Just because we can do something, should we do that? And then, who benefits from my action? Who is hurt by my action? What are the consequences here? That's a good question for any architect of any system. What's going to happen to the system when it's deployed, when it's used in the real world? And what are the unintended consequences? And when those unintended consequences happen, as will happen all the time, what do we do to mitigate that? And how will the people affected by this technology react? Not how we think they should react, not how we know they'll react once they're properly taught, but how will they react at initial rollout? And you can see the consequences of people not asking these awkward questions in Facebook's dilemmas right now. Mark Zuckerberg had to testify on some of these questions, all of which were under the umbrella of legal decision making, but senators had some serious ethical questions about Facebook's behavior with our data. And right now, this last month, Google ran into the same problem where they hadn't thought through the consequences. So Duplex is Google's new kind of human-sounding AI that can make phone calls for you and answer the phone for you. But Google severely failed here because they failed to ask the complicated questions of ethics when they designed the algorithm. So they worked on Duplex for many years, and they could understand the nuances of conversation. If you've seen this, the AI will say, uh-huh, I hear you, really react like a normal human being. And yet, as the quote in many newspapers pointed out, it was yawningly absent the idea of ethics, that they had not thought through how people would react when they were not told they were interacting with a machine. This is a problem, and this is what we have to deal with in technology, that we have to anticipate these questions being asked. And we have to be ready for those questions rather than being caught with our pants down. So when we start thinking about autonomous vehicles, like this car here, we also have to start thinking about what are the ethical questions. So I've put together a series of steps that I think help people to think smarter about algorithmic design. So first of all, treat this as an engineering challenge. Don't treat it as some sideline. Don't treat it as a tertiary option. This should be core to your design. So what's technically possible? What's ethically justifiable? And what's legal? Those are three legs of one stool. So you obey the constraints, of course, but you optimize for all of these different ethical options. So think through these ethical decisions, not as an afterthought. And identify all the stakeholders. Don't just have the people at the table who are building it. Have consumers. Have people who are actually going to use it. Have people who are going to be affected by it. Have all of these stakeholders come together and think about the technology before you roll it out. And please reject groupthink. Don't let your team all look alike, talk alike, share alike, agree alike. If everybody's agreeing, something's wrong. If you don't have someone at the table who says, I think this thing is screwed up. We need to change it all the time. Keep that person at the table. You see this picture of a team. This team would really help you succeed in 1952. This is not the right team for today's technology. If you have this team, get a new team, because that's not what consumers look like anymore. These are not the guys who are going to help you build the smartest system that's going to dominate the world. Instead, get a diverse cross-section of human beings. For example, this team won't get you there either. Even though it's a different set of people, it's all the same type of people. This team won't get you there either. Again, not enough diverse voices at the table. This team might get you there. This is one of my teams at Intel. And we have people at Intel who represent every language in the world and every culture. And sometimes that makes decision-making really hard because people have different opinions and different ideas and different cultural assumptions. But that makes us better every single day because all the little decisions in your algorithm, all of the small points of inflection that you make in your technology, that's what makes your technology better. In that diversity is our strength. So also demand people at the table who will give inputs that you're uncomfortable with. Ask about implicit bias. Ask about unintended consequences. This is not just future-proofing your technology with a usability study. This is asking hard questions about what's going to happen when users have concerns. So go into the comfort level of technology. This is something that Google failed to do. Ask about what's going to happen when information leaks. What's going to happen when people understand what's under the covers? Is that okay? Do consumers know what the buttons do, and are they comfortable with that? And this goes to some academic ethics. Immanuel Kant, who's a famous German philosopher, said, ask in such a way that if everyone did this, this would be a world that you would want to live in. In almost every episode of Black Mirror, they take this to its logical consequences. They say, if we took this technology as it is today and we extended it so everybody was using it, is that where you'd want to live? Black Mirror asks these interesting questions almost every week. Immanuel Kant asked it about stealing. If you have one person steal, that might be okay. If everyone was stealing all the time, is that the world you'd want to live in? So again, you're not a neutral actor. Your technology decisions are not neutral behavior. You're designing something that you want to be pervasive. Everyone who's designing technology wants your tech to be on everyone's desk and in everyone's pocket. If that happens, are you okay with that? And profit doesn't have to be the only motive here. Intel has shown that if we're proclaiming our ethical behavior and being clear about it, that actually pays substantial dividends to our shareholders. The act of designing ethical software does not have to be a zero-sum game. We can all win here. And finally, it's important to think about your system as potentially being compartmentalized. This is a gun, okay? Guns are put together in such a way as to kill people. In most places on Earth, if you manufacture a weapon or you manufacture a device that can be used for unethical decisions or can injure people, you can be sued for it. This is not the case in the United States, but this system can be taken apart, can be compartmentalized, just as we're seeing with Docker and other container technologies. You can compartmentalize your algorithms and your technology blocks so they are not so easily used for unethical or illegal means. So what about this? What if you took apart your technology into its component parts and forced a technology integrator or even your end user to make decisions about what they're going to put together when in order to take action? So that's one way that you can constrain the unethical use of your technology. So for example, here's a computer vision pipeline. This includes pre-processing, modeling, deployment of all of these components. All of these components, as we saw earlier, have different aspects of decision-making built into them. When you're inferencing, are you matching against other models? When you're evaluating, are you clustering using TensorFlow or another inference engine? Are you doing collaborative filtering, and are you matching against a remote database? Do you have access to that data? Do you know how it was sourced? All of these components have different pieces that have ethical implications. So here's some practical next steps for business decision makers. Assume responsibility. Imagine that you will go to court or you will be testifying to the Senate and you have to answer for your technology yourself. Not some corporation, not some distant investor, but you yourself. Are you comfortable with those decisions that are being made? Don't offload that to some imaginary other person. You might be personally responsible and called to account. Secondly, place a value on ethical decision making. If you don't reward the people in your corporation who might want to report some concerns, people will not report that. If ethical decision making does not have a real value, your team won't do it. So reward people for acting ethically and reporting questions. Don't punish them. And finally, try to take your algorithm to a third party. That could be an internal ethics body. It could be a decision-making body in the broader industry. There are many of these being formed now. Google and Microsoft are contributing to decision-making bodies to advise on ethical behavior by companies. And then when all of this happens, own the outcome. State it explicitly. These things will be there in the tech. Don't try to conceal it. So those are for business decision makers. But when we talk to people designing technology, I have another list that takes these recommendations and spells them out in more detail. So, practical next steps for engineers. First, seek input. This is good for any architect. You want to ask holistically, what is this system being used for? And why am I designing it? Don't try to design in isolation. It's a good question when you're designing any system. What am I doing and why does it matter? Ask that question. Seek input. And then try to expose your API. Your interface should be accessible, and try not to create black boxes that have levers that can be pulled invisibly. Instead, expose your interface. Expose the functions. Explain it. Document it so people understand what is happening underneath the hood. This is absolutely critical. If you don't do that, you can actually be held liable for what's inside that black box. Third, and this is actually pointing a finger back at marketing or business decision making, all too often, wrong ideas proliferate around what's possible with technology. Wrong explanations end up in marketing. You can take ownership over that and explain, sometimes over and over again, but you can explain what's actually happening in the tech and why it matters. State explicitly what the technically accurate algorithm is. State explicitly what it's actually doing. And finally, as I mentioned, try to containerize or compartmentalize the different pieces of your tech so that they can be used individually or separately. So these two recommendations of rating and safe should allow your teams to be smarter about designing tech. And as we get into tech that will be more autonomous, this becomes more and more critical. You have to embed moral principles into your technology systems. So that's, in a nutshell, ethics and algorithmic design. I don't have clear, crisp answers, but I do have a little bit of forward-looking ideas about what could happen. So here's one way of putting my recommendations into practice. So this is using something called blockchain that I know you've all heard of. So let's talk a little bit about how the blockchain ledger could be used to design more ethically rigorous technical systems. So this could even provide an enforceable mechanism for technology deployment. So blockchain could allow for moral traceability on each component. You remember that algorithmic stack that we have here with images, locations, all the details that you can get in that whole stack? What if you could actually tag each of those components and put them in a ledger and tag them with origin of the tech, what it was designed for, what the license constraints are on it, and perhaps who the original author of that algorithm was, so that you can trace it all the way back. In this stack here, you can actually see where each and every component came from and what it's used for. So you could identify there is a problem right there, the red one. That's a problem with the tech here. If we remove that one, or if we identify that as being a problem, we can actually change what the stack is doing. So right here, we could establish a chain of custody, establish a chain of moral culpability, and you can also give a company assurance that their components might not be deployed to a war zone or might be only deployed under the terms of their license. So if you have everything in a ledger, you could actually pull out components that are not allowed for that scenario. Right now, we're running into this with Amazon and Google facial identification algorithms being used in war zones. Employees at Google have pushed back hard. Employees at Amazon have not. But the actual enforceability of that is exactly the same. Employees at Google don't know if their facial identification algorithms are being used in war zones. They only have the word of the company and the Defense Department. something like this in blockchain could actually provide a traceability element there. So there are some downsides. There's no right to be forgotten in blockchain, and there's also no way of changing the blockchain later. So that's a summary of some of the ideas around where blockchain could take us in ethical decision making. So this is Ned Hayes for AI, Ethics, and Algorithms. Thank you.